Hello students, welcome to Vista's Learning. This is Shruti, your chemistry tutor. We are in Vista's Learning where you get the quality education for all. We work for right quality education for everyone. Yes, we are in chemistry and we are in 11th standard. Let's get into our chapter. This is the new chapter which we are starting now. This is 9th chapter in chemistry, the name hydrogen. And this is our first lecturing class of hydrogen chapter. Got it? Since we know hydrogen which have one electron and one proton, and this is the first member of periodic table. We have already studied. We'll just know a much more thing about this hydrogen. Here you can see hydrogen has the simplest structure. As we know, hydrogen has a simplest structure, isn't it? Yes, obviously, because it has only one proton and one electron, only one ring or orbit around the nucleus we have. So it is the simplest structure which we can see among all other substances or elements, and it has only one proton and one electron. Isn't it, students? Isn't it correct? Yes. So next point is that hydrogen exists as a diatomic molecule. That means one molecule of hydrogen. As we see here, we have one atom of hydrogen with one electron. So it is not stable. It requires one more electron to get stability, and hence it will take other hydrogens' help and they become a molecule. They share electron. Each electron will be shared by both the atoms of hydrogen and they get the hydrogen molecule as H2, and hence we call it as a diatomic molecule. So hydrogen exists as a diatomic molecule and we also call it as a dihydrogen. We can call this as hydrogen molecule as well as dihydrogen. Got it? Good. Next thing is that it forms many compounds than any other elements. That means it can combine with many other elements to form a new compound. If you see here, the hydrogen, the blue color one is the carbon, white color is the hydrogen. So 4 hydrogen combine together with 1 carbon to form methane. Likewise, 3 hydrogen combine with 1 nitrogen to form ammonia. Next, we have 2 hydrogen atoms combined with 1 oxygen to give water molecule. Likewise, we have many compounds formed by this hydrogen. So we can say hydrogen can combine with any other elements to form a new compound. The next one is that it has a great industrial importance, where you can see the electricity can be produced from this hydrogen. We can use as a fuel. We can use it as a fuel for running the vehicles too, and it is also eco-friendly. You can see it is very abundantly found, and so the amount will be also less compared to other fuels. So this is where, and you have to know this one, this is combustible. Okay, it easily catches fire, and this is a very good fuel where will not get a pollutant released. If you take other like carbon, when you have been releasing, it releases carbon monoxide, carbon dioxide, where here hydrogen will not give a pollutant. So it is a flammable. We can also say it is inflammable compound or a element. So next one, we have to know about the position of hydrogen in the periodic table, where it has been exactly positioned. Can you say, is it in the first group or in the 17th group? Why we are taking first and 17th group? Because it is having similarities between first group and the 17th group. We'll just check where we have to position this hydrogen in the periodic table. Hydrogen is the first element in the periodic table, that we know, and it has the electronic configuration as 1s1. It is similar to that of alkali metal, where we can see ns1 is the outermost electronic configuration for alkali metals, that is group 1 metals. Next we have it also have electronic configuration which is similar to that of halogens, because hydrogen requires only one electron to finish its K shell. That means stability, to get the stability. So halogens also require only one electron to attain stability. So it has the similarity between the alkali metals as well as the halogen. How we can see about the electronic configurations. So hydrogen has resemblance to alkali metals which lose one electron to form unipositive ions. As we know, hydrogen can also lose electron and become H plus ions, whereas it also can gain one electron and become H minus hydride ion. So here it can gain one electron and form a uni-negative. This is uni-negative. Uni means one, negative means negative charge. So uni here, one positive charge. That means one electron will be lost and it becomes uni-positive. One electron has been gained, it becomes uni-negative. Uni-positive is similar to that of alkali metals, whereas uni-negative is similar to that of halogens. So it has the similarities between halogens and alkali. Next we have electropositive character of hydrogen. Hydrogen can form a unipositive ion, as we just discussed, same thing. They have the loss of electron can be possible with hydrogen, only one electron can be lost, so it gets a unipositive ion. Example, sodium has 11 electron in its outermost, it has 11 electrons and 1 electron in its outermost shell, so it can easily give out 1 electron. Likewise, hydrogen can also lose 1 electron, so it has the similarity with the alkali metals. Oxidation state, if you see, hydrogen exhibits oxidation state of +1 ion as the compounds of hydrogen, which is similar to that of alkali metals, and valency of a hydrogen is 1 as like of alkali metals. So reaction with non-metals. How the metals or alkali metals reacts with other non-metals, even hydrogen forms the binary compounds with other non-metals. So it has the similarity like alkali metals. Reducing nature. Yes, hydrogen is a good reducing agent like alkali metals. So next we'll compare the same thing with the halogens. So halogens are electronegative in nature. So nature of hydrogen, which is similar to that of electronegativity. Hydrogen has a tendency to attract electrons like halogens. So that is also possible. If you see, hydrogen can add up with 1 electron and become hydride ion. Remember, if we have H minus 1, we call it as hydride ion. If it is H plus, we call it as proton or hydronium ion, hydrogen ion. Okay. See, chlorine is also gaining 1 electron because chlorine has 7 electrons in the outermost shell. It requires 1 electron. It gains 1 electron and becomes Cl minus, and we call it as chloride ion or chlorine ion. So you can take the examples here like bromine, iodine, fluorine, any of the halogens, they will be almost similar to this example. Oxidation number. In addition to oxidation number of hydrogen, which is having +1, it also have the -1 state like halogens. If you see here NaH, when hydrogen is reacting with the metals, it will get -1 charge, where metals will get +1 charge. So when metals are reacting with hydrogen, hydrogen acts as an electronegative element. When hydrogen is reacting with non-metals, hydrogen acts as an electropositive element. Similar like that of halogen, NaCl, Cl will have -1, Na +1. So oxidation state, if you see, chlorine and hydrogen will have similar oxidation state, that is -1. Valency of hydrogen, as we saw, it will be -1 like halogens also. Reaction with metals, just now we saw hydrogen combined with metals to give binary compound similar to that of halogens. So Na reacts with hydrogen, dihydrogen to give NaH. where Na reacts with Cl to give NaCl. Atomicity. What do you mean by atomicity? Do you remember the first chapter concepts of basic chemistry? We have studied in that atomicity. Atomicity means number of atoms present in a molecule. So atomicity of this hydrogen is almost similar to that of halogens. You can see chlorine, bromine will be diatomic molecule. Similarly, halogen is also a diatomic molecule, and hence we can call atomicity of hydrogen is similar to that of halogen. So hydrogen also differs from alkali and halogen as well. We see hydrogen is reacting like alkali metals as well as the halogens, and it also has some differences with alkali and halogen, or deviations from alkali and halogen metals. The first thing what we can see here, where we should place this hydrogen. By seeing these properties, we can say the hydrogen can be placed in first group, or else it can be placed in 17th group. Where to place this? We have a doubt whether to place it in a first group or else in the 17th group. So what we do is that we place it separately in the middle of the periodic table, as it has both the characteristics of alkali metals as well as halogens. Got it? Good. Next point. Loss of electrons from hydrogen atom results in nucleus. That means you have only nucleus. There is no electrons at all. Only proton is present. At that time, the size will be 1.5 into 10 raised to minus 3 picometer. Picometer means 10 raised to minus 12. Okay. The size of the nucleus can be found easily by loss of electron from hydrogen. Extremely small as compared to the normal atomic or ionic size of 50 to 200 picometer. As we say, atom of hydrogen is entirely the less in mass, as well as it is the lightest element. It also have a very small size, and this is where we can define and we can say the size of the atom hydrogen is very less. H plus does not exist freely. Yes, it will be combined with other element, as it is associated with other atoms and molecules. It cannot be easily found. Thus we can say it is unique in behavior and best placed separately in periodic table. Got it? We are placing the hydrogen separately from the periodic table. Next, dihydrogen. What are the things we can see in this? Occurrence and the preparation we'll see. So how do you and where do you find this hydrogen, students? You remember hydrogen is in the gas, air, what we see, atmosphere? Yes, it is. And it is not only in the atmosphere, it is there in water form also, because we know water is made up of H2O. So hydrogen abundant, the universe is made up of 75% of water, whereas in that we have hydrogen, right? So hydrogen is the abundant element present in the universe. We'll see principal element in solar atmosphere is also hydrogen. Even in Jupiter and Saturn consist mostly of hydrogen. It occurs in plants, as we see. We all want water. Not only water, the carbohydrates, hydrocarbons, whatever we use in our body, most of them contains this hydrogen. So the tissues what we are having in our body will be made up of hydrogen, carbon and oxygen. That is the basic thing, right? We know. So there hydrogen is required. So it occurs in plant and animal tissues, carbohydrates, proteins, hydrates, hydrocarbons and much more compounds. We'll just check here. This is a helium and hydrogen where we find 70% of the total universe is made up of hydrogen. Got it? And if you see here, the earth crust is finding 15.4% of hydrogen. We know oxygen is abundant and carbon is there. With that, in the earth crust we have hydrogen 15.4%. And coming with this atmosphere, we have 0.15%. Why we have less amount of hydrogen in atmosphere? Because it is least or less in weight. So we find everything in earth crust and universe, whereas we get very less in gaseous state. Got it? Good. Next we can see here the isotopes of hydrogen. As we know, students, isotopes means the atoms of same element which have different number of protons. Protons? No, it is neutrons. Okay. Excuse me. You can see here we have 3 different hydrogen atoms where excuse me, each one is having 1 proton, 1 electron, 1 proton, 1 electron, 1 proton, 1 electron. What is the difference now? The difference is this is called as protium, this is called as deuterium, this is called as tritium. Where you can see H1H. That means that here 1 electron, 1 proton and 1 proton is there. There is no neutrons. But I have written here 2. That means what? We have 1 electron each, where here deuterium should have 1 more mass number. Where we get? It is neutron. That means protium has 1 proton, 1 electron, whereas deuterium has 1 proton, 1 neutron and 1 electron. Got it? What about this tritium then? It has 1 proton, 1 electron. But we can see here 3. The mass number is 3. Atomic mass is 3. So how do you find out 3 there? Here 2 because 1 neutron has been added. What about here? Here 2 neutrons are added. That means the electron and the proton are same in all the 3 isotopes. Only neutrons are changing. Since neutrons are changing, atomic mass changes. Atomic number remains the same, as atomic number is equal to proton and electron. Proton, number of protons is equal to atomic number. Number of electrons will be equal to atomic number, but number of protons plus number of neutrons will be equal to mass number. So mass number will be differ in all the 3 isotopes. These isotopes will have same chemical properties but differ in physical properties. Why? Because the mass will change. The mass changes means the physical properties change, but the chemical properties depend upon the electronic configuration. Since all are having same number of electrons, so chemical properties are not disturbed. Got it? Next, abundancy of isotopes of hydrogen. If you see here, we have 3 isotopes, as I said, protium, deuterium and tritium, with different mass numbers. Their relative atomic mass is been given here, and you can see the abundancy of the given isotopes percentage, where 99.9% the protium is present. That means most of the hydrogen atoms are of protium, whereas the deuterium is 0.0115%, whereas tritium is 0.003. Very small traces of amounts of tritium is present. Okay, we need to know one more thing about tritium, is that we can also say that tritium concentration is about 1 atom per 10⁻18 atoms of protium, and this tritium is radioactive. Whatever it is present, that will decay. So it emits a low energy of beta minus particles, and we have the excuse me, we have this half-life for tritium, where 12.33 years. So this is a radioactive element and it is not stable. Tritium is mostly not stable, hence will not get this abundancy of tritium here. Got it? Good. Next, we need to know about the preparation of hydrogen. Whenever we get into the chemical properties or the chemical substances or elements or compounds, the thing how we see is that from where we get that element. So occurrence, then preparation, then physical properties, chemical properties. Got it? So we'll just check with the preparation of hydrogen. How many types of hydrogen can be prepared? We can prepare it in commercial method as well as in laboratories. So laboratory process how to find out the or prepare the hydrogen is, first one is granulated zinc which reacts with acid. Here mainly what we can do is that, students, we know that when metals react with acid, hydrogen is released. When non-metals reacts with water, hydrogen is released. When metals react with hydroxyls, that is bases, hydrogen is released. So all the three bases are there. On those three bases will be having zinc here. Zinc reacting with hydrochloric acid. So when the zinc reacts with hydrochloric acid, what happens? Zinc chloride is formed and hydrogen gas will be liberated. Is it balanced, students? It is not balanced, right? So we need to add 2 here such that it will be balanced. Okay. So next one is that it reacts with aqueous alkali. Alkali means base. So when it is zinc has been reacted with, you can take any of the metals. We are taking zinc here. When zinc has been reacted with NaOH, sodium hydroxide, we get sodium zincate with the hydrogen gas liberated. This is where we use the laboratory process. Now coming back with the commercial preparation of dihydrogen. So in industries and factories, how this hydrogen is produced. If you see, this is an electrical supply where we supply the electricity to the water molecule, and then from there we get the hydrogen and oxygen gas liberated. We'll just check it here. Electrolysis is a process where we can pass the electricity through the substance and dissociate them. So here, electrolysis of acidified water using platinum electrode gives hydrogen. So this is the equation where we have water passing through the electricity. We get hydrogen and oxygen gas liberated. So mechanism works like this. The hydrogen splits in presence of acid. So it splits into H plus and OH minus ions. At anode, what happens? OH minus comes and anode is negatively charged. So this negative charge will go near this OH and we get OH with the removal of H minus. So H plus gives you water molecule, removal of oxygen. One oxygen, other oxygen combines together to form oxygen molecule. And at cathode, what happens? This H plus ions will be present. The H plus ions gains the electron and forms HH atom combined together to form hydrogen molecule. So we get hydrogen here as a gas which has been liberated at cathode, where you can see at anode oxygen gas has been liberated. To obtain high purity, that means if we want here we got previously electrolysis, oxygen and hydrogen. To get only the hydrogen with a higher percentage, we can use this high electrolysis of barium hydroxide solution, where we can get the nickel electrodes used in this process to get higher purity of hydrogen gas. Hydrogen is also formed when a steam reacts with hydrocarbons at specific high temperatures with some of the catalyst. For example, if you take methane, when methane reacts with water at 1070 Kelvin, remember it's a very high temperature, 1070 Kelvin in presence of nickel to produce carbon monoxide and water. This production of carbon monoxide and water will be called as water gas. You can see methane is reacted with water. This is gaseous water. That means it is having a high energy. Hence methane reacts with gaseous water, that is steam, and gives carbon monoxide and gas, hydrogen gas, which has been liberated. This will be called as water gas. And this water gas is also called as syngas, where this is used to synthesize many other hydrocarbons. So we can call it as syngas. You can see here we have the synthesis of methanol and many other hydrocarbons using this syngas. So we call it as because that is synthesis of other elements. So which is been used for synthesis, we call it as syn gas. Synthesis gas is prepared from sewage, scrap wood, sawdust and related materials. You can also use this and prepare the syngas. Syngas can be obtained from coal, and this process is called as coal gasification. The increase of the production of hydrogen gas can be done reacting carbon monoxide of the synthesis gas with the steam in the presence of iron chromate as a catalyst at temperature 673 Kelvin. That means we got here, right? Water gas we get with carbon monoxide and hydrogen gas. We need to remove this carbon monoxide. So what happens? We can use this reacting with water. We get carbon dioxide plus water molecule. So we also call this as shift of water gas reaction, where carbon dioxide can be easily removed by scrubbing with the sodium arsenate solution. If you take the sodium arsenate solution and scrub with this, carbon dioxide will be absorbed and we get the hydrogen gas. Here 77% of hydrogen can be prepared by petrochemicals. Petrochemicals means the products of petroleum products, whatever we get from there, we can produce this 77%. From coal, 18% of hydrogen can be produced, whereas 4% can be produced from electrolysis and 1% can be produced from other sources. This is about the production or preparation of hydrogen. So now we'll just know about some of the physical properties of this hydrogen, dihydrogen. So what is this dihydrogen? Is it colorful? Do it have any color? If you take iodine, it will be having violet color. If you take bromine, it will be having brown color. What about hydrogen? It is colorless. Got it? So it is colorless gas and it is odorless. Odor means smell. You don't have any smell of this hydrogen gas. It is tasteless. You can also doesn't have any taste. Okay, if you inhale this, you will not get any taste of it. Okay. Combustible gas, yes, it catches fire soon, so we can say it is a combustible gas. Hydrogen is the lighter than air. This is the important thing, where it is very lightest element. It is insoluble in water. We know carbon dioxide is soluble in water, oxygen is soluble in water. Why oxygen is soluble in water? Do you know the advantages of that? When oxygen is dissolved in water, aquatic animals and plants can easily utilize that dissolved oxygen in water. Here, this is not soluble in water. That means hydrogen is insoluble in water. These are some other properties, physical properties of hydrogen, where you can see the relative abundance. We just discussed about all the three isotopes. We have the melting point. If you see the melting point of hydrogen, it is 13.96, where for deuterium it is 18.76, for tritium it is 20.62. As the mass increases, melting point also increases. We have boiling point, density, enthalpy of fusion. Fusion means how you can fuse it. And we have vaporization, how fast it vaporizes. We know this cannot be vaporized because tritium is a radioactive element, so we cannot get that in the vapor form, but we can find the deuterium and hydrogen in the vaporization, or we can find out the enthalpy of vaporization. Likewise, we have the bond dissociation, intermolecular distance between the atoms. We can just check it out. The comparison is, this is almost same. Okay. Other than that, you can find the covalent radius and ionic radius of hydrogen, and these are some of the basic physical properties of hydrogen. Any doubts, students? Did you understand this? Fine. By this we finishes our session today. So as we said, this is the hydrogen. I just started with this hydrogen chapter. Other chapters, whatever we have finished, if you have not looked through it or if you have missed any of the videos, you can get back to our web application www.v-learning.in. And thanks for watching, students. Keep signed in with us for more videos.